Hey, good day. Hey, going to introduce you here to the 550 Adept robot. I know you guys wanted to see this go, so therefore we're going to make a little video. There in front of us is your standard 550 robot. Pretty simple thing. 4-axis Scara robot. Obsolete, but they're little workhorses. They work pretty good. Attached to the robot, you do have a controller. Now you're looking at two controllers. I'll zoom in on one, the one that's hooked up there. It's set up right now with the 030 processor, the SIO, the serial IO, which contains a hard drive, the A drive, and associated IOs for your use, and then we also have the VGA card. That's your joint interface card that interfaces with signals to the robot. I am working this right now off of a VT100 straight ASCII terminal. That's how I'm running it. Also available, of course, is interfaces for standard monitor, keyboard, and mouse. There, right in front of you, there is the amplifier setup. It's a 4-place amplifier setup. You only have 2 amplifiers. They're dual amps, therefore it takes care of the 4 channels. Running between there and the controller is the interface cables, and then down and around to the robot is the ARM signal cards. Also going from the robot to the processor is another cable for ARM signal interface encoders, SIO, and whatnot. I'm going to walk over and just hit the start button. It is going to get a little noisy on the tape there. The robot will go through its self-test, whatnot, checks the processor, whatnot. Does default to the A drive first. That's a setup thing. We do not have any systems in the A drive right now, so it will load from the C drive. C drive's an onboard old style SCSI laptop drive. Matter of fact, does use proprietary formatting. It doesn't use sectors and whatnot. So they pretty much got to be made on the system. Successfully loaded. It's going to load the system on there. The robot is doing nothing right now. The e-stops have been made, therefore you do hear that the amplifiers come up. And if I zoom back a little bit, you can probably see that the lights came on the amplifiers. There, it is successfully loaded. I am now going to load a program I had on there. There we go. And it's going to load the programs, all the locations I've saved, also every other program that was probably ever on this machine. I haven't really cleared it off. My program itself is a very simple program. Just whirls the arm around a little bit to give you a demonstration of the thing in motion, because that's what everybody likes to see. Now I'm going to type in the calibration command, and it's going to ask you if I'm really sure of this. Calibration can be done automatically through programming, which you would do on an autonomous cell, or it can be done on the manual control pendant, or it can be done through a command entered manually. I'm now going to pan over to the robot so you can watch it calibrate. Let's zoom out a little bit here. What it's going to do is calibrate each axis individually, and then it should return itself to the ready position, which is the arm out in front of it in a lefty configuration at 90 degrees. Sorry Sorry about the delay, but I did forget to enable the powers on the amplifiers, which is a good thing. It'll bring each amplifier up one by one. Right now it's doing joint 3, which is the Z-axis on the quill. Go up and down. It's got a couple of sensors in the arm, catch positions, catching encoder positions. Compare them to a stored position, which is in a non-volatile RAM in the base of the robot. Does the twang. That's to figure out on the 3-phase power of the motors. There are little 3-phase motors in there that they do respond. We'll check each one. Then it'll go to what's called the ready position. And there it is. It ended up in the ready position. Now I'm going to load that little program that I call Go. And you'll be able to see the thing run around. And I had this default up to the 50% speed, so you'll see this thing just whirling around at 50%. And I stepped the speed up to 75%. Step it up to 100%. Now this is just mounted on a plywood table. You can see that it's going to be rocking a little bit, but it's never fallen off yet. Of course, you would be on a 1-inch thick or better steel table, and it wouldn't have any problem. Right now, my accelerations are extreme. They're at 100%. Therefore, it does a very robotic move. In a production environment, you would want your accelerations to curve up better, to ramp up, to make it more rounded corners and whatnot. Saves on wear and tear of the robots and doesn't give it that real robotic moving. I'm going to go down to 10% speed, just so that you can see each motion that it's doing. I've got 6 or 8 points in here. I don't have any delays. There's no end effectors on here or anything. Other options you probably could include on this would be the front control panel that Adept supplies. It is not necessary in a fully integrated work cell, probably not really necessary. You may or may not already have a man-machine interface. And the other is the manual control pendant, useful for setting things up. I've seen work cells that they use them as the man-machine interface. Handy little thing to have, but not necessary. They both plug into the SIO, actually the main control pendant plugs into the front control pendant, which plugs into that. But what you would be supplied with a bare system is just this little plug here and there that just has the jumpers for the safety circuits. Alright, so then we got the little robot running around there. Now for spare parts, I got spare parts. My God, you look around the shop, there's 550s there. Oh, there's 550s there. There's controllers. Stacks and stacks of controllers. Let's take a little walk down this way. Oh my God. If you look down that way, oh, it's a virtual graveyard of 550 Adepts. We did strip out a couple of major manufacturers of their production lines. Most of them